Hey everyone. So now we're going to move on to looking at the parameter module and some of the methods that we can do with parameters, whether to sort of fetch them and work with them or to then actually, once we've got a parameter, what to actually do with those. Okay. So obviously, as I'm sure you know, parameters are what is on top of a node, right? So all of these controls, these are parameters, and they usually have a name and then a label. So in this case, for example, the label is translate with a capital T, so sort of a human readable label, but then the actual parameters are called tx, ty, and tz, right? So and that's the name of the parameter. So keep that in mind as we go forward, because of course that's incredibly important when working with scripts, because code usually refers to the name, not the label. Okay, so with that out the way, I want to show you first how to grab a reference to a parameter. So even though we're talking about parameters, we're actually starting again on the who.node module, but in this case it's actually a subclass of that called who.opNode. The who.node, you'll notice, does not actually have a parameter sort of section over here, and if we search for parm, you're going to see that nothing actually comes up. Also, just so you know, the word parm is sort of a shortened sort of alias for a parameter is in Python, well, in the sort of Houdini Python. So everywhere where you see parm, just know that that means parameter. Okay. So the reason there's no parameter methods for who.node class is because essentially the who.opNode class, so operator nodes, are the defining feature of these is that they have parameters. Okay, there may be other aspects to it, but one of the main things is that anything that has parameters falls under the category of opNode, whereas you can have other nodes. In fact, I believe, remember I said that the obj is actually sort of counts as a node. Well, I believe that that would actually fall under the category of who.node, but the who.opNode has actual parameters, where obj, the sort of context, does not have its own parameters, right? So there's a whole bunch of subclasses for opnodes. So all of our different, ROPs and SOPs and DOPs and all of the different ops. But opnode is the parent class for that entire category, and these are the things that actually have parameters. So we're looking at the opnode class, and you'll see a whole section for parameter functions. Okay. Now, likewise, how we could drag and drop nodes into our either Python shell or the source editor. You can also drag parameters in. So I'm going to start simple over here and actually drag in the uniform scale, and I'll sort of talk about why just now. But if I drag it in, you're going to see it just says who.parm, right? So we are essentially bypassing the node step to this. So if I search, I'm going to actually open a new tab over here, and I'm going to search who.parm, and you're going to see there's the parm class, but there is also a who.parm hom function, right? And what this is, so this is part of who. So if we go to the main package, it lives in this list, the same as who.node, which has obviously there's the class, but remember we have this method over here, who.node, all lowercase with circular brackets, and that's how we reference a node. Well, we can do who.parm, and okay, there is the class, but there is the actual function. So this is asking us to give it a path to the parameter itself, but that path would then include the node, because that is essentially the address where that parameter lives. It lives on a node, so we would have to give it obj_go1 and then whatever the parameter name is. So we are essentially giving it the path to the node anyway. But I just want you to be aware that you can reach access to a node in multiple different ways. One of it is to just skip straight to the parameter itself. So we go who.parm and then the full path, which is obj_go1, and then our parameter name is scale. If I hover over it, you'll see there that the parameter says scale. And that gives us our reference to our node, okay? Our parameter. So now we could print p, and you'll see that is our parameter. But we can also access it through this opnode list. You'll see there is a parameter function as well, and that is a method that is specific to the opnode class. How this works is essentially, instead of doing the full method like that, what I'll do is I'll create something called p2, and we can do who.node, and then we reference our node, so /obj/go1. Remember, we are using this method. We do not need to call who.opnode, the actual class. We just use this function to grab a reference to a node. It will know what type that node is, and in this case it's an opnode, right? In fact, it's an object level node, so it may even be a subclass of opnode, but at least it will inherit, so it'll be there a who.obj node, but it will inherit the methods from opnode, including all these parameter methods, right? So p2, I'm now referencing our node through a function, which obviously this returns an instance of a who.opnode type. And then I can run another function on that, so .parm. And then I'm just giving it the parameter name, not the full path to the parameter. This may seem like a longer method, but it's very important to know, because most of the time you are going to have maybe a list of nodes that you've gathered from running a children function or a selection function or something. So it's very easy and quite common to have a list of a list of nodes that you then need to find the parameters on. So then you'd just be looping through them and just for every node just going .parm and then referencing the parameter on that node. Okay, so even though it's sort of a two-stage process, it's very common to have them separated. You can obviously access it directly this way, but if you do have the path to the node, I would recommend, rather than actually building this complicated string by merging the path to the node plus the name that you're looking for, it would actually be better to just reference the node and store that in a variable and then reference the parameter, because then you have the node reference as well and you can repetitively reference that node. So it's a little bit better to do it that way. Either way, you're going to get reference to it. So you'll see if I go print p2, there we go. I'm pointing at this to the same object. Okay, I'm just getting there in two different ways. Okay, so that is our parameter, but there is another type that I want you to be aware of, which is parm tuple. So this is another class, and obviously we know what a tuple is. So a tuple is, you know, a list, well, an immutable list, but a list nonetheless. And in this case, what it refers to is basically a type of parameter in Houdini that is more than one value. So even though it is one parameter, it has sort of a sub-components to it, and so it counts as a tuple. Those components, the most common one is 3. So like this over here, tx, ty, and tz are actually just sub-components of this parameter called translate. The actual name of this, and it doesn't really say it, which is a little annoying, so you kind of just have to know this or understand it. But the x, y, and z part of this is the sort of component tag. So the name of this parameter is actually t. The label is translate, but the name is t. That's the name of the parm tuple, whereas the name of each component individually is tx, ty, and tz, right? So there are actually 4 names that you could reference in here, but it's basically, you need to differentiate between whether you are referring to the entire tuple, in other words the top level, which contains subcomponents, or whether you're referring to each individual value as its own parameter. Okay, so who.parm would be able to reference tx, but who.parm tuple will reference t. Okay, so if I click and drag translate into our, let's just do it into the Python shell, you'll see it's automatically going to fill it in as who.parm tuple and then the path to t. And like I say, nowhere if you hover over here does it actually specify t, that you just see tx, ty, tz, but that is actually the name of the parameter. And if you go to the parameter sheet and go to translate, you'll see there that it does actually say that the name is t, right? But because of those different components, it sort of automatically places that XYZ on it. Now sometimes it's XYZ, sometimes it's UVW, sometimes it's 1, 2, 3. That depends on the actual tuple naming convention, which is a thing that you can change. I'm sure we'll cover that later as we get more into doing parameters through like in HDAs. But for now, just understand that there is a name for it, which is a name for the tuple, as well as a name for each component, which is essentially the tuple name with the component appended to it. Often it's XYZ, but sometimes it can be 1, 2, 3. All right. So you'll see there, these are all tuples, right? Obviously that's not a tuple, that's a single value. Okay, so depending on which one you want to reference, so like over here we could say, I'll just call it PT equals, so Parm tuple equals. So PT is this Parm tuple, and now I can run functions on that Parm tuple, similar to what I'd be able to run on the parameter, but the values, the results are going to be a little bit different. Okay, so keep that in mind, because as we progress forward, I am going to sort of probably in a lot of cases show you both the Parm or the tuple, but even if I show you only one, just know you can probably apply it to the other. So you should, especially when learning this, you should have both the who.parm class and the who.parm tuple class open, and you can kind of compare and see like, okay, so the first method we're going to be talking about is name. You can check whether or not it exists on both, and even if it does exist on both, whether or not it has any differences, like maybe there would be an additional argument or an optional argument under the Parm tuple where there isn't on here. So it's important to understand the differences, because they are defined as completely different functions, right? They're not even inherited from each other. They're simply kind of like parallel methods. So they may actually have different arguments or return something different. For example, a lot of the time on the Parm tuple, it's going to return a tuple as a value, because it's going to then give you, if you evaluate the parameter, it needs to give you a tuple because it has 3 values, whereas if you evaluate just the X component, it has a single value. Okay, so let's get around to that, but very important to understand the difference between Parms and Parm tuples. Likewise, the op node function, well, the op node class has not only a Parm method, it also has a Parm tuple method over here. So you could go this method as well of referencing the node and then the Parm tuple rather than having to reference it directly. Okay. Either way, it's going to return an instance of a who.parm class or a who.parm tuple class, and then you will be able to run these functions on it. Now let's start with name. Okay, so we'll go, I'm going to create just foo and say foo equals p dot name. It takes no arguments. I'm just going to print foo, and you're going to see there it gives us the name of our parameter. Likewise, if it was p2.name, it's still going to work. And let's say we wanted to reference, instead of a parm, but a parm tuple. So in fact, what I'll do is I'll override p2 with a parm tuple. So we'll have well, 2 examples, pt and p, just so we can kind of compare every function we run and see whether or not it can work with tuples as well as with a single value. Okay, so there we go. We'll go pt.name and print it, and you'll see that it prints t. Okay, right, so name, pretty simple. We're just asking for the name. Evaluation. So let's talk about this. Parms, they always have a value, right? There are different types. Like we have drop-down menus, we have floats and integers, all these different types, but ultimately they store a value. So when you reference the parm, you don't just automatically get the value. You are talking about the parameter itself, okay? Not the value within the parameter. So you have to actually ask it to tell you the value. And I've noticed a lot of people make this mistake early on in their coding. So they go, oh, I want to grab this value, so I'm going to reference the parm, And it's like, no, that is just pointing to the parameter itself as an object. Okay, you still need to actually do something with that object, so you need to read the value from it. Okay, it's kind of like saying, tell me the time, but like the first step is to refer to your watch. But if I just pointed your watch, I'm kind of referring to the watch itself. I might be asking like, oh, what brand is that, or is that comfortable, or how much did you pay for that? But I'm just pointing at the watch. I would have to ask you, right, use your watch and tell me the time. I especially have to ask for one particular information from the watch, which is the actual time, and then you are returning that value. Even though that's the primary thing that the watch is there for, it's not automatically assumed that when I refer to the watch that I am asking for the time. I might be asking other information about it. So keep that in mind. When you refer to a parameter, you do not have the value, you have the parameter itself. Right. So let's read a value. Now there's lots of different ways you can evaluate a parameter. So I'm going to show you several because you will come. This is probably the most common thing you're going to do with a parameter is evaluate it. Okay. Obviously parameters store values. So the main thing we're going to do is say what value do you have. So if we refer to a parameter, so let's go to our who.parm class over here, we have the option to fetch the value from a parameter, and you'll see how many different types there are, right? But the main one is eval. Okay, so I say dot eval, no arguments, and it's going to return. Now actually you'll see here this one returns multiple different types. It doesn't actually return all of these types in one go. It's just saying it can return any of these types, so either an integer or a float or a string. Okay, so we evaluate p, and it's going to give us the value of p, which in this case is 1.0, right? Or pt we can evaluate, and it's going to give us a tuple. So if we go to parm tuple and eval, you're going to see that it's going to return a tuple because of course we are referring to a tuple, right? If you wanted just the tx value, you could either refer to this, fetch the tuple, and then grab the first index like that, or you could, instead of referring to the parm tuple, you could say who.parm, and then it would be go1/tx, right? Refer to the parameter, not the parm tuple, and you will get a single value instead of 3 values. Now, just a normal evaluate is going to try and sort of figure out what what type it wants you to return and how it should return that information. So if it's a float, it's going to want to give you a float in return. But you can try and sort of tell it how to give you that value. So you can evaluate it as an integer. So we could say p.eval as int, and then it's going to actually in this case it's not able to do that because it's just not the right type. Okay, so it's basically just you have to kind of use this on the correct type, but at least it's a way of sort of saying, right, I definitely need to make sure this is an integer, so if the user has given me the wrong parameter, then it's going to throw up an error, rather than if I just evaluate it, then I have to do some type testing to check. And so this is why you get this kind of error if you try to evaluate it as an integer, right? There's other things you can do. So you can deliberately evaluate something as a string. So evaluate as string, and then in this case it does actually work. You get a 1, but that is a 1 like a character, an alphanumeric, like an ASCII kind of 1, not an actual integer 1. So you would have to convert this if you wanted to go back to something like an integer or a float. And evaluate as string, eval as string, is actually probably one of the most important ones to know, because a lot of the time it gets it wrong if you try to evaluate something. Even sometimes when I feel like it is a string, it will try and sort of give it to you as a number. You really have to tell it, like, no, just seriously, I want it as a string. I want the actual text. And then also another very important one is unexpanded string. Now this one doesn't actually have the word eval in it, but you can see over here it makes reference to this, and this is very, very important. So what you can do is say p.unexpanded unexpanded string, right? Now, in this case, it's not going to work because it isn't an actual string. So let's give it a, let's say this, what is this one called? Shop material path, right? So shop material path. So this one's not going to let you give it the wrong type, but what it is going to do is evaluate something as an unexpanded string. So what we can do is, let me test it with just a simple variable like $f. Unexpanded string will do that, but eval as string is going to give us the actual value. So if I move my frame number and evaluate it, it's 79. But if I do unexpanded string, $f, okay? So it's essentially giving me the expression, not the result of that expression. Okay, and that'll work with variables, but it'll also work with if you have like an an expression, an H expression. So you've got a backtick and you've got some kind of expression like a pad 0, 2, comma that or whatever, right? So you're able to evaluate this as a, like if I go below into single digits, it's going to do a double padded value. If I do an unexpanded string, I'm going to get the whole text. If I do eval as string, it's going to give me the result. Okay, so very important to know that one. There are other ways of fetching the expression if it is specifically an expression, but still very good to know unexpanded string. I also will use this as an opportunity to say that you don't have to, just like how we could refer to the parameter directly, or we could refer to the node and then on the node run a function that fetches the parameter. We can also skip straight to the evaluation of a parameter rather than having to refer to the parameter. So you can do who dot eval parm, and now this is skipping straight from the beginning. This is not even going through a node. So we're dodging the nodes part and the parameter part and just jumping straight to feeding it a path to a string, well, sorry, a path to a parameter, and it's just giving us the evaluated version of that parameter, right? So if I run that, it's who.evalParm, and it just wants a path all the way to the parameter. And then it doesn't give us a reference to the node, it doesn't give us a reference to the parameter, it simply gives us the value of the parameter, right? There's a sort of a halfway step for this, which is that you can say who.node, so you can still refer to the node, so obj_go1, but then you can .evalParm and then just feed it the parameter, and likewise it will give us just that value. Okay, so if you have the node but you want to skip the referencing of the parameter and then evaluating it, you can just do this. But this is basically the same as doing .parm, and at the end you can also just put .eval. Okay, so lots of ways you can write this. Okay, I actually think though, I just want to double check, but eval, I think there are fewer, if you want to skip all those steps, there are fewer ways to evaluate it. So if you want to force it to evaluate as a string, you're better off referring to the parameter and then saying .eval as string, because I think if you try to do okay, on the parameter, but even on the node, let's see, eval, so even on the node you can only eval parm or eval parm tuple, but you can't really force it to evaluate as a string. Whereas if you actually reference the node, like the parameter itself, then you can run any kind of evaluation. Like evaluate as a string, as an integer, evaluate at a certain time. So you can even basically do like a sort of a time shift, but just for that parameter. So there's lots of very cool things you can do with evaluating, but you have to first be referencing the parameter. But if you want to do it in one line like this, you can. So you can just say .parm and then .eval, because obviously this function is going to return a parameter, and then you can just evaluate that parameter. So you could say at this point unexpanded string, and that would still work in one line. Of course, you then don't get a reference to the parameter, so if you want to refer to the parameter multiple times, you're better off doing it in 2 separate steps and storing the parameter as a variable, then just running an unexpanded string on that variable. But if you know you're not going to reference it and all you want is the value, then you can do it in one line but still have the option of doing the more advanced evaluations like this, rather than having to just do the sort of who.evalParm, you know, or node, who.node.evalParm, and then in that case you get a lot less control. Okay, right, so that is evaluating, and there's a whole lot of different types. Now you can also, when you refer to a parameter, you can also ask for the expression. All right, oh, hold on, let's go to the parameter. Look at expression. Now this is looking for the expression on that node. I think in this case these types of inline things don't count as an expression. It's more that if you have something that's referencing, so it's like if we copy and then paste relative reference, no, again that is a so if we do that, paste relative reference, so now it's an actual expression, then it's going to return that expression. Okay, if it's a string expression, so in other words like this, where it's just got a backtick and wants to so like actually that, if we paste relative reference like that and hit apply, it doesn't work. So you'll see the who dot operation failed. It tells us that the parameter is not animated. Now, I'm going to talk about this in a second, but well, I might as well talk about it right now. Basically, when you see these parameters that go a different color, so if I copy this and paste it as the translate X, for example, and it changes color, although it's an expression, so we can say edit expression and see what this expression value is, it sort of internally counts as a keyframe, right? So it counts as having animation even though we have not set a traditional keyframe but rather an expression. So if I go and refer to this parameter, so that is stored in P, in fact, actually I'm not going to refer to the parm tuple, I'm going to refer just to the parm, I'm going to do tx, okay? So now P is referring just to tx as a who.parm. If I call P dot expression, it's going to give us an expression and not have that error that says it is not animated. In fact, if we say there's another expression called delete all keyframes, this one is one I really wanted to show you. Delete all keyframes can be used to basically remove expressions from a node. Okay, delete all keyframes with an S at the end, right? So if you want to get rid of an expression, you have to use this method called delete all keyframes. That should be an indication to us that it treats expressions as keyframes. But also important to know that that does not mean these types of string expressions where it has just got a backtick and it's trying to do sort of like a string evaluation of a Houdini expression. I know this is really confusing, while some work one way and some work another way. And you do have to know all of this, because if you're going to maybe you want to check a parameter's value for whether or not it's an expression, and maybe you want to bake that expression value. So you want to evaluate it at this current frame and then kill the expression and replace it with just the value from this current frame. You know, you need to actually check, first of all, whether or not it's actually animated at all, which may mean it has keyframes, but it also may mean it has expressions instead of keyframes, or whether or not it has a string expression instead of a sort of just a static value, right? So it becomes complicated, but you do have to know all this and you have to actually check for it. So you can use methods like unexpanded string to check whether or not there's a difference between the unexpanded string and the actual string value. You can check whether or not there's an expression by checking if it has keyframes. So over here we can list all the keyframes, and it's going to give us a tuple of all the keyframes. And so you can say p dot keyframes. It's going to list the keyframes, which in this case is an expression. I don't know why it counts as a keyframe, but then what you can do is check the len of that. So it's returning a list, but what you can do is check how big that list is, and if that list is greater than 0, then it means it is animated. Okay, so I know it seems super weird, but you have to literally do the keyframes and then take the length and check it greater than 0. Now you know, okay, this is how we check whether it's animated. There might actually be some short ways of doing it. Maybe anim will give us some results. Sometimes I notice like there's an expression that I was never even aware of, and I've been doing it the long way, and it, you know, whether or not they've added that expression recently or I just missed it. So definitely check multiple sort of ways of, you know, like, so is it going to be under anim? Is it going to have the word keyframe? But as far as I know, this is the way to check whether or not it actually has an expression, is, well, to first check whether or not it has any keyframes. But then what you can do is say p.expression, right? And then it's going to actually return the expression. Now, instead of an expression, let's say we actually just put keyframes on our y value, and we switch from tx to ty, and we say, we try to call for the expression, it's not going to work. But if we say dot keyframes, then it does work, right? So these are some of the ways that you can essentially evaluate whether something has like true keyframes or whether it has an expression that is actually counting as a keyframe. Right, so you can also, when you ask for an expression, so we'll go back to our tx, you can ask whether or not it has, well, what the expression language is. I believe also that if there is Python, so you change one of these to a Python script, it will still count as a keyframe. It just has a different expression language. So let's say we go and set this. So you'll see actually to force this to be an expression without entering any code, the first thing we do is actually make it a keyframe. So I alt left click on it to make it a keyframe, and then change its language to Python, and then come edit expression. And what I can do is say this should be equal to who dot, let's say, frame. Okay. Wait, is it low? I think it might be a lowercase f. Yeah, lowercase f. So who dot frame, right? So now that is 31 because our frame number is there and it's changing. Okay, so there's another cool expression for you. It's just who dot frame, also who dot time. So this now has a Python expression. If I switch this to TZ, so it's referring to that, and check the expression language, it's going to be expression language dot Python. But if I check just the expression, it's going to return that. So it does count as a keyframe. If I also ask it for keyframes, it's going to show me that list of keyframes, and if I ask for the len of the number of keyframes there's 1, which means it's either an expression or there's just one actual true keyframe. So next, let's talk about setting values. So this is obviously a very common thing you're going to want to do with parameters as well, besides reading the values, is actually setting it. That includes setting it with keyframes or expressions as well. So let's just look at a very simple version where we can set a value. So we'll start with our normal parameter, so p.set, and then we just feed it a value. We'll get to the optional kind of arguments afterwards, but let's just say set a value to 2, all right? So there we are, our uniform scale has been set to 2 because we fed it the value. It's pretty good at figuring out what type. So of course, if you are setting a string type parameter, and then you feed it value, generally you're going to put it in quotes and feed it an actual string. Okay. Now if you do feed it, so let's try and see what happens when we do feed it something that should expect a string, but instead we set it with a value of 2, which is not a string. It's just going to give an argument. It's a type error, sorry, not an argument, but an error. So it's a type error saying, hey, this is expecting a string, but in fact you're trying to give me an integer. So you know, with one expression, we don't have to change the different types of expressions, but you do need to feed it the right type. Okay, so be very careful of that. Same with the parm tuple. There is a set, although there's a clue in the name there, which is that it has a plural. It wants values, not a single value. So we can say pt dot set, but it's going to expect it to be set to a tuple as well. So over here, this is the translate, which is 3 different values. If it's 3 values, it wants us to give it 3 different values. And keep in mind that those are still a single expression, a single argument. So we need to wrap that in a tuple or a list or something. It wants some kind of array of 3 different values so that it has some value for each of the components. So we cannot just say, so if my values are 3, 4, 5, you can't just say set 3, 4, 5, because that's going to not be the right number of arguments. Or in this case, it's actually, there are 3 arguments, but they expect different types, because it thinks that 3 is the value for values, and then 4 is the value for language, and then 5 is the value for follow Parm references. And that's not true, because these should be booleans. Well, actually that should be a boolean. This should be a type of who.expression language, and this should be a tuple. So this is incorrect. However, if you wrap it in a tuple, then it's going to set those values correctly, 3, 4, and 5, because it actually separates those values. Okay. Obviously, you can have tuples that are not just 3. You can have some that are 2, some that could be maybe 9 or 16. So if you've got matrices, so that is all possible. So just make sure you feed it a tuple of the right number. And if we feed it just a single value in there, it's also not going to. So it's not even just enough that it is a tuple. It has to actually have the right number of values. Okay, so be very careful of that. Now there are some optional arguments for this. Most importantly, we need to look at this one that says language. Now this actually tells us a really cool thing. It's kind of a little trick or sort of a hidden thing you can do in Python with these expressions. So just like in Houdini, where you can copy a value and then say paste relative reference, and it just easily creates that reference without us having to write this expression or turn this into a keyframe. Well, you can do the same thing using the set function. Now we're going to talk just now about the set expression function, but this is kind of a quicker, faster, like simpler way of setting just a normal parameter reference. And you'll see it tells us specifically that this language is only for when, so it only applies when we're setting it to a who.parm value. What that means is that in place of value, instead of feeding it a value, we actually feed another parm, a who.parm reference. So I'm just going to store this one in X, and let's say we reference the, maybe I'll grab rotate, but you'll see by grabbing rotate, it wants to make it a parm tuple. Instead, I'm just going to make it a parm, and then it's just going to be Rx. So I'm referring to this first one here instead of the whole tuple. And now if I say set p, so p.set, but the value is instead x, it's not going to set the values to be the same. It's actually going to make an expression. So if I say apply now, right, oh, hold on, why did that not? Oh, actually it did. I forgot that I switched to our material. Let me go back over here to setting this to our uniform scale, just so we can stay on the same tab. So if I hit apply now, it's made our uniform scale equal to the parameter reference of that particular parameter. Okay. Now, if you wanted it instead to fetch the value from it, but in one line, you can say .x and then eval, right? So you're evaluating the value and then setting it, and now it will just make them equal. So let's say this was 10 and this one is 5. When I hit apply, it's going to make this equal to 5, but it's the value. If you feed it the actual reference to the parameter, then it makes it an expression. And the language, which by default is none, if it's set to none, it will take the default language, which in this case is HScript, but you can override that by pointing it to be a Python reference. If you want to do that though, you have to feed it a who.expression language type. This, if we middle click, is a separate module. The module only contains 2 values, which is that, and it's the full thing, who.exprlanguage.python. So that is the one type, or the other type is HScript. This is what gets returned when we do a expression type method on a parameter, but this is also what we can feed it when we want to tell it the language. So you can't just put in quotes Python or whatever, feed it a string like that. You actually have to say who.expr language.python, but you'll see it helps us fill it in, so you can even click those and it will fill it in for us. And then of course we can now, when we click apply, it makes a Python version of a reference. So now I can hit 8 or 10 or whatever, and this will be referenced, but it is using Python instead. We can come to edit expression. You'll see that's our code in there, and it has changed itself, changed language to Python. Okay. Please note that on the Parm tuple for this exact same trick, it expects a who.parm tuple. So it wants you to say, right, let's test this over here. So I'll say xt, so it's x, but it's a tuple, and I'm going to refer to maybe scale over there. So I'm basically setting translate to be equal to scale. So now we're going to say pt and set it to be xt. I'll take away the language because we will just do the default language. So if I say that this tuple should be equal to that tuple, but without evaluating it, then of course it's going to set x to be x, y to be y, and z to be z, right? Which is exactly what we would expect in that scenario. But instead, if I just feed it a single one, so I say that pt should be equal to x, it's then going to give us an error because it's not a who.parm, it's a who.parm tuple, right? And it expects this to be a tuple, and it's not. We fed it a parm instead of a parm tuple. So please be aware of that. If you want to go and set that, so all of them, let's say tx, ty, and tz should be equal to one value, so uniform scale, you want to put it in each of the 3 components, you would actually have to go to the 3 different components or loop through them by taking the Parm tuple and grabbing the parameters from it. Keep in mind that you can do that. So you can, from the Parm tuple, you can get item, and it's going to give you a who.parm. So you could actually go to this Parm tuple and say, so pt, and then in square brackets 0, because remember our magic methods, get item, and we feed it the index. That is putting the square brackets with the index number in there, is fetching that. But what it's telling us here is that when it fetches it, it doesn't just fetch the value, it actually fetches a who.parm of that particular index. So we could say pt, and then in square brackets 0 dot set, and then we could set it to be equal to p, which, remember, p over here is our uniform scale, pt is translate, okay? But it's the whole translate tuple, whereas if we want to set x, y, and z to all be equal to the uniform value, then we would do this. So 0, 1, and 2 should each be set to be equal to the parameter reference scale. And so what that's going to do when we hit apply is that they will all 3 be linked to scale. And so now I can change this one value and it will change all 3 at the same time. Okay. Right, so that's the Parm, the set function, and an easy way of making parameter references. Then there is set expression. So on a Parm, so let's say on P, we can set the expression, which is essentially creating a keyframe and then sort of clearing, well, inserting this expression as the value for that keyframe. So it sets a keyframe essentially on frame 1, right? And then we can also feed it a who.expression language, which we know can be either HScript or Python. Now, I just want to point out as well that if we go back to set, you'll see here it spoke about this. If you don't want your channel references to kind of chain together, you may want to delete the reference, any basically expressions on the parameter that you're about to set before you override it with a reference. And it tells you how to do that, which is through who.parm.delete all keyframes. So I just wanted to point out, we've already spoken about this before, but you can see here these help files sort of tell you how to work with it, and delete all keyframes as a way of getting rid of any expressions and references. Anyway, so same kind of deal here, even though it doesn't mention it again. If you want to, you can clear the keyframes before setting the expression, which is a good way of ensuring that you don't get chained together parameter references. Right, so here you want to feed it the expression that you want, then tell it a language, but by default it will be HScript, so if that's all you want, then that's fine, and then replace expression true, so if that's false, then it's not going to allow you to replace it if there's already an expression, right? So pretty straightforward. Let's say we wanted to set our expression over here to be something like $f greater than 10. So it's sort of a Boolean function where it's 0 and then it goes to 1, okay, depending on frame number. So that's our expression that we would like it to have. So now we can say .set expression. The expression is going to be a string, so it tells us a string containing the expression that will go inside the parameter, so you do need to make sure it is included in brackets, right? Single quotes or double quotes, especially if you're going to have CH and sort of a reference with single quotes, then you could wrap this in double quotes so that it doesn't break, because otherwise, of course, single quotes and then let's say I'm trying to reference something at /obj, whatever, you'll see this is opened and then closed the quotes, so be careful of that. If you put the double quotes, then this is the quotes for the string, but then within that there is single quotes that refer to the path within this expression that we're trying to feed it. Okay, but in this case we're doing $f greater than 10 is our string expression, and in the language I can actually leave it out because I know I just want that to be HScript. Okay, and then also replace expression true by default is usually what I would like. So I hit that button and I'll now get an expression in there, and it makes it a keyframe that is frame 1, has that keyframe which holds the expression. Okay, important to note that Parm tuples do not have a set expression. Okay, they only have a set. You can get an expression in it using this parameter reference trick, but you cannot just set a normal expression. You can, however, set a keyframe, and since I've been saying that keyframes and expressions are kind of the same thing, or at least expressions are keyframes, but keyframes can include actual keyed values. It wants you to feed it a keyframe vector, but that keyframe vector, it wants it to be of a type who.base keyframe, and if you create that type correctly, that keyframe can have an expression. So then you could actually create a vector of these three instances of a who.base keyframe class embedded inside of a tuple, and feed that as a keyframe vector that could be used in a set keyframe expression, and then yes, it would set that expression on all three. It is possible to do it that way. I personally think that's a very roundabout way to do it. I think the easiest way is very similar to what I showed you just now. You would go PT0. So you'd refer to the Parm tuple and then in the individual component and rather set that to be equal to something. So let's say you wanted them all to have the same, you would just do the exact same thing. PT1.set expression and so on, and feed the three different expressions in that way. I think that's probably the easier way to do it, but if you really want to, you can go the roundabout way of giving it a vector of type who.base keyframe, and then the who.base keyframe class, you would have to initialize it correctly, including giving it an expression. So you can actually set the expression language, and so you can set the expression including the language and build a keyframe and then store that in a tuple and then say who.parmtuple.set keyframe, then you feed it that vector, and then of course you'll end up with expressions in 1, 2, 3 components. Okay, a little bit more complicated, but maybe there's a case where that is the better way. Right. So that is kind of a lot to do with setting and setting expressions. There is another thing that happens though when you set expressions, sorry, not set expressions, but just set a value, just change a value on a parameter, and that is that it sort of triggers a callback. We're going to talk later a lot more about callbacks, so you'll understand what that means, but essentially it's when I change this value, it triggers something. Something actually happens. and you can attach a script to that. So then whenever I change this value, it runs a script. Not only does it change the value, but it also actually does something else, which can trigger a whole cascade of things to happen. Now, we can trigger the callback without actually changing the value, which is quite a neat thing to be able to do. And that is through an expression called press button. Now, the most common use for this is to actually press a button, because a button is basically a parameter that you can think of it as a Boolean, right? It's 0 or 1, but it's set to 0 all the time. And as you click the button, right, we don't actually have any buttons on here. Let me maybe find something that does have a button. I think transform has a few buttons like this. So move center to origin, okay? It's sitting at the value of 0, but as I click it in, it basically becomes 1 and then becomes 0 again just almost instantly, right? Although it doesn't actually trigger 2 callbacks. It doesn't change to 1 and then change to 0. It just sort of very temporarily holds a 1, and it triggers 1 callback. So if we ever want to use Python to essentially press this button, let's say we wanted to drop a transform node down and actually move centroid to origin, then you can refer to that button parameter and tell it to press the button. Okay, so buttons can be referred to like any other parameter. So who.parm, and then there we are, that's the name of the parameter. And you can evaluate the value, so we could print p.eval, but it's going to be quite boring. You're going to see that the value is just always 0, right? It doesn't even matter if I've clicked it, it's still going to be 0 because it goes 0 back to 1 and then back down to 0. So that's not really going to help us. But you can say p.press button, and this essentially just triggers, I'm going to just actually bring it up here in our oh no, sorry, I'm in the who.parm tuple, but let me do it in our who.parm just so you can see the arguments, which in this case there are none, but well, you can actually feed it some arguments, but these are for if you want to run the script with any arguments like control was held while, because sometimes you can control click a button and it will actually run that script slightly differently. So you can actually feed it arguments where even through Python, when it presses the button, it's as though it has control clicked the button instead of just press the button. So that's what this arguments dictionary is for, but you don't need to give it that. It's got an empty one by default. So you can just say press button and it will press the button. All right, so we click that and it actually runs that button. Okay, so let's, if we had to set everything back to default, just set all these values back, and then we click this again. It's like we clicked the move centroid to origin, and you can see here that everything is set to not be at default. For example, very specifically, our scale was 1 and now it's set down to 0 when we click that button. Same thing happens now when we click apply. It runs that button. Okay. But it's important to note that something really cool that it does is triggers the callback without, even if it's not a button. So let's say there is a callback on our rotate, it will trigger it. Another really useful thing that we can do is essentially ask Python about any existing references. And this can be super useful to essentially traverse any kind of dependencies, check what's, before we delete this node, we can see if anything else is referring to it, or sort of go to all of those nodes and change the expression to refer to a different node so we can reroute it before deleting this one. There's a lot of things you can do. Now, if I just show my dependencies, so show for selected, you can see that all 3 of these are referencing this this node. It's because I've got my uniform scale referenced on all of their uniform scales, right? So I just created that and then duplicated it. And of course we can hover over this and I think, does it give us? No, it doesn't even tell us what it's referencing. It just says that there are references, which can be a little bit annoying. So now we can use Python to say, hey, give us that more information. Obviously here we can check node references, and it's going to show you which ones are referencing this node and nodes referenced by this node. but now we can do that in the script as well. Okay, so I'm referring to my my node over here as P, and now what we can do is you'll see it under who.parm class, we can say get referenced parm, so that returns the referenced parm, and then parm's referencing this, right? So in this case we would want to use the second one, p.parms referencing this, and it's saying basically this parameter, whichever parameter it is that we want to point to, which, oh actually sorry, I'm referring to my node only. Instead we would want to refer to the parameter, so I'll just add a .parm, and then scale is the parameter that I'm referring to, and if I hit apply, oh well, I would have to print that. Don't forget that it's just giving that value. I actually need to print the value. It's going to give me 3 different who.parms. So it's this parm, which is a scale. This is the name of the parm on Geo2. Well, in this case, Geo2 is called scale. So on that node, the parameter called scale is the thing that is referencing this. Okay, so parm's referencing this. But then you can also get referenced parm. So we could do it the other way around. Basically say this node dot parm scale, and say get referenced parm, and then it's going to print scale on obj geo1. Okay, so we're going just the other way and saying what is the parameter that this is referencing. So I'm going to show you a last few things to do with parameters. These are not necessarily going to be used all the time, but they can do some pretty useful things, especially if you want your script to kind of control the way that these parameters are displayed. So we're talking about everything under this sort of metadata section. So one of them, for example, is hide or is hidden. So what you can do is check if a node, a parameter is hidden. You do get hidden parameters, and of course you might be able to, like, you know, if let's say you're looping through all your parameters, well, maybe when you reach hidden parameters you don't want to apply a certain block of code to that. So it's really good to be able to ask if a parameter is hidden. But then there is also the ability to actually change it to be hidden. So you can say hide, and then it's either on or off, right? So we can say p dot hide and true. Okay, so we tell it, yes, you should hide this parameter, and there we go, that whole parameter is now hidden. Okay, now it hasn't changed GeoNodes itself, like it hasn't changed the, you know, basically the HDA description of that, not that GeoNodes are HDAs, but sort of functioning like that. The default node has not had that hidden, but the sort of the spare parameter version of that node, of that parameter will be hidden. Okay. And because we are referencing it still, we can actually change that back to false and bring it back. Or while it is hidden, we could also ask whether or not it is hidden. So we could say p dot is hidden, print that, and we would get a value true. But obviously if we then change it to be false, do the print after the change, then it's going to say false because it is no longer hidden, and there it is. Okay, so hide is one thing. Disable is another, pretty useful. A lot of the time you want to create a parameter, maybe a spare parameter, but then immediately disable it so your user is not actually adjusting that parameter. So you know, it's like you're setting something, but maybe it's just referencing some other thing, and you don't want it to be altered by the user. You just essentially for display purposes or something, or you want to create a parameter to store some values. Then you can create it and either hide it or disable it or something like that. So very similar. You can disable equals true, and so let's get rid of that. So we can disable that. So now it'll be grayed out, and we can't just drag and change that value. Actually, something that's really useful with this is making things not disabled that usually would be. So sometimes you actually come across a node that is disabled, and what you can do is force it to be not disabled. Okay, so now we can make that not disabled. Likewise, you can ask, is it disabled, and it's going to return a boolean. So very straightforward. And then lock as well. Lock is pretty cool, which you can lock things manually. You can right click and go to man, they moved this around. Is it channels? No. I'm trying to think where it is, but you can actually lock nodes. Like, I mean, lock parameters. Maybe it's paste on. No, it's not. Oh, there we go. Lock parameter. So you can lock it like that, so that it doesn't change, and you can unlock. Right. Likewise, you can do it. Lock. True. And there it is. And now it's sort of grayed out. So even if we change the value, it's then going to jump back to the value it had before and not let us change that value. But of course, you can then lock and unlock it as you wish through the code. Okay. Of course, if it's locked, your user can come and unlock it. Whereas if it's disabled, I don't think they have a way to disable it other than through code. I don't believe there is a way. So disable might be the better way to go if you really want to force it that they cannot change that that value. Okay. Usually disabling and enabling is done because of some, it's another expression, so it'll say only when this toggle is on or off, then this changes its display. But then of course you can then say disable false, and then it will not disable it, which is kind of overriding what that other expression is doing. So it's stuff that you can not do without using code, which is what's quite handy. All right, so those are a couple of just interesting things. I hope a lot of these expressions that we've covered in this lesson are very useful to you, but more than anything, I hope that they cover some of the sort of the ways of working with parameters and nodes and the sort of relationship between them. So are you referencing the node and then the parameter on that node? So are you working with the who.node parm like class, or are you using the Houdini module to reference the parm directly? There's a lot of tricks to do with that, so I hope this has helped clear some of that up, because we will be, working with nodes and parameters is pretty much our bread and butter, right? That's most of Houdini is just nodes and parameters, as well as then the next lesson we're going to cover geometry. Those are the big three. And once we know how to work with nodes, work with parameters, and work with geometry, you should really be able to build a ton of different scripts in Python. Obviously, that's not everything. There are more outlying modules, but those three types of classes, you can pretty much do most pipeline tools with that. So I hope this is really useful, and I'll see you in the geometry lesson.